Hey everyone, today we want to talk to you about our Aula project. As engineering students, we spend a lot of time thinking about how to fix problems, but some problems are more urgent than others.
Exactly, we decide to focus on safety, specifically on fire hazards. When a fire starts, every second counts.
Usually in older systems, you rely on a person seeing the alarm, seeing the smoke, pulling an alarm, and then waiting for the sprinklers or the firefighters. But we thought that human reaction is too slow. That's why people panic or they might not even be in the room when the fire starts.
So, our goal was simple. We want to create a system that doesn't need a human to make a decision. We want to design an automatic fire detection and suppletion system. The idea to the idea is to have a machine that can sense danger and act on it immediately. Protection both its facility and the people inside.
Now, I want to clarify something important about WeWare right now. A project like this have two main lives, the theoretical life and the physical life. For the past few weeks, we have been working heavily on the brain of the system.
Right. We didn't want to just buy a sensor and tape into walls. We want to build a logic that makes sense to for industrial environment. We besides all the design of a PLC, which stands for Programming Logic Controller.
Think of the PLC as the director of an orchestra. It's the computer that sits in the middle waiting for signals. We spent a lot of time designing the diagrams and their logic flow.
We had to ask ourselves questions like what happens if a sensor fails, or how do we make sure the water pump turns on at the exact right moment? This part wasn't about connecting where yet. It was about solving the puzzles on paper to make sure a system is foolproof.
Okay, so let me explain how the process actually works in our design. It's basically a chain reaction. First, we have the inputs. These are our sensors, basically the rays and noise of the creation.
They are constantly monitoring the environment. If they detect a smoke or a rapid rise in heat, they send a signal to the controller.
And this is where the magic happens. The controller receives that signal and processes it instantly. It doesn't hit state. Once the logic confirms there's a fire, it activates the outputs. In our case, the main output is the suppression system, like a water pump or a sprinkler.
It's so simple, right? Detect and spray. But developing the logic to make this smooth was a challenge. We had to make sure the code helps the system distinguish between a real emergency and a false alarm. That's what we have been developing up until now, a solid, really logic structure.
This brings us to the current status of our Aula project. If you look at our work today, you will see a complete engineering plan.
We have the objects defined, the programs are drawing, and the programming logic is ready to be tested. However, we're currently in the transition phase. We're moving from the designing world into the real world.
To be honest, this is the most exciting and probably the hardest part. We haven't built a physical prototype yet. We know that things work perfectly in a simulation, but the real world is messy.
Our next big step is the physical assembly. We need to actually wear the PLC, connect the sensors, and build the physical structure that represents the room we're protecting. We expect to face some challenges here, like reading issues or calibration problems. But that is a part of the learning process.
So, what is the next for us? The plan for the coming weeks is to take all this documentation and turn it into a working machine.
We want to able to like a small far in front of our sensors and watch the system react on its own. Exactly, we as programmed it to do.
In conclusion, this Aula project isn't just a homework assignment for us. It's been a process of understanding how automation can save lives. We started with an idea, we developed the logic, and now we are ready to build it.
Thank you for listening to our process so far. We can wait to show you the physical result very soon.